We have them in our homes and in our cars. They come in large sizes and compact. They make living in Florida bearable, and inversely, the units can be set to bring warmth on cold winter nights. From their 1842 inception by physician John Gorey to their 1902 mass production by Willis Haviland Carrier, air conditioning units have become essential to the everyday lives of modern Americans. But what happens when they don't work right? When design flaws put ideal temperatures just out of reach? Heat sizzles, and cold bites, and utility bills soar. It's all part of the consequences and inner workings of usability design. Since the dawn of history, design has been the key element to man's success. Whether the results are spectacular or just spectacular failures. They can make complicated tasks simple. And simple tasks very complicated. Isn't it great when a plan comes together? And it's all made possible through the magic of usability design. We're here at an undisclosed apartment in beautiful Tallahassee, Florida. It may be paradise, but here, summer temperatures can soar well into the 90s with high humidity in this coastal climate. But the city is also far enough inland that winter temperatures can dive into the single digits. With such extremes, it's no wonder it was a Florida doctor who first conceived the idea of air conditioning. But what happens when the home cooling system doesn't work right? This is usability design, hot and cold, when air conditioners go bad. This apartment complex used to be a hotel. It was remodeled to house residents by connecting two rooms into single units, one with the standard bedroom, bathroom, and closet, and the other adapted into a living room and kitchenette. But this raised challenges of connecting utilities like electricity and water, as well as environmental control. To cut costs, the original air conditioners beneath the windows from the complex's days as a hotel were kept. However, only the unit in what became the living room remained as the bedroom air conditioners were taken out. Now, designers were faced with the task of climate control for a two-room apartment with units only designed to handle one. To overcome this, technicians installed a short series of ductwork directly above the unit that releases air into the living room before spurring off to a vent that delivers air into the bedroom. Unfortunately, this system is not powerful enough to condition both rooms simultaneously, so air will only flow through the shortest path into the living room. This vent must be sealed off manually with heavy objects such as books to redirect air into the bedroom. Furthermore, a gap between the original unit and the added ductwork allows air to leak out into the living room when it's supposed to be directed into the bedroom. Unfortunately, increasing power, better division of airflow between the rooms, and side panels extending below the original unit to improve airflow are functional issues beyond the scope of this usability analysis. However, one small design change could dramatically affect the tenant's ability to use the current system as efficiently as possible. Adding a vent cover to the living room that is controlled by a small lever, not unlike most home air conditioning vents, would eliminate the need for heavy objects to be sought and placed by users to redirect airflow, saving time and cost, and increasing aesthetics and efficiency. But this isn't all. In addition to the haphazard rigging of the secondary duct system, the controls on the original air conditioner are even worse. Right away, it is evident that the two elements clash, as the lid covering the buttons on the air conditioner is partially blocked by the ductwork above, limiting access to the control panel, particularly to users with large hands. Ideally, the secondary system would have been designed to allow free passage of the door, but designers would have at least been better off removing the cover to maximize accessibility to the controls below. The unit is regulated by two knobs, One, a simple dial marked by 10 dots that sets the temperature between warmer and cooler, and the other, a similar dial that rotates between high heat, low heat, stop, fan, low cool, and high cool. It is difficult to determine when a setting is reached and even possible to leave the knob halfway between two marks. Additionally, the high and low, cool and heat settings may confuse the user as they only regulate the power with which air is being put out and does not make the air hotter or colder, a scenario made even more confusing by the dial-like operation. This function would be better served by a pair of switches, one toggling between warm, fan, and cool, and the other sliding between off, low power, and high power. The first knob, however, is the one that tenants may find most costly. Users may be led to believe that this will regulate the temperature of the air being released by the unit. In reality, however, it regulates the temperatures at which the system will turn on and off when sensed to maintain a constant climate in the room. Though even with this knowledge, the indicators, labeled 1 through 10, leave users guessing as to what that temperature might be. With no guidance, it is easy to set this value too high or too low, resulting in uncomfortable conditions and potentially increasing energy costs for the user. Notice also how lower values correspond with warmer temperatures and higher values correspond with cooler temperatures, unlike typical thermal applications. By simply labeling temperature increments like common household air conditioners, these usability problems can be virtually erased. So don't lose your cool this summer. Staying chill is easy if you have an air conditioner. And of course, good usability design.